Hi everyone. The topic we are going to see today is CPU scheduling algorithms. Under this, we have already seen FCFS scheduling and shortest job first scheduling. In shortest job first, we have seen preemptive SJF and non-preemptive SJF. In today's session, we are going to see about priority scheduling. Priority scheduling is nothing but each and every process which was arrived and staying currently in the ready queue will be assigned with an priority number. The priority number, which is the smallest, will be having the higher priority, and the largest number will be having the lower priority. As we have seen in SJF, the priority scheduling also have two types, preemptive and non-preemptive. Let's see an example for both preemptive and non-preemptive in this session. In this, the main problem which will be arriving will be starvation and aging. Starvation is nothing but the lower priority process will be waiting for the CPU for larger amount of time without the allocation of the resource. This is known as starvation. And aging is the time got increased for the process allocation. This is known as aging. These two will be mainly occurred in priority. Okay. Then, as we have seen in previous sessions, you know what is a Gantt chart? That's nothing but an bar chart, and waiting time is the time period spent in the ready queue, and turnaround time is the total time of the waiting queue plus its execution time. Okay, and these are the formulas which are used to calculate the turnaround time and waiting time. Turnaround time equal to completion time minus arrival time. Waiting time equal to turnaround time minus burst time. Okay, this is the given process. We have four processes, P1, P2, P3 and P4. Namely, the arrival time of the process is given along with this burst time and priority. Okay, as we have said, the lower number has the highest priority, right? In this, the P2 has the priority value of 1. So P2 has the higher priority in this 4 process, and the largest number has the lowest priority. So P1 has the value of 3. P3 has the value of 4. So P3 has the lowest priority among all those 4 processes. As said before, we can solve the same problem under preemptive and non-preemptive. If we solve this problem under preemptive, we will be getting this Gantt chart first displayed, and for non-preemptive, we will be having second Gantt chart. What is the difference between preemptive and non-preemptive? Let's have a glance. The thing is that for preemptive, we will be having, if a process is allocated for the CPU and another process with the higher priority arrives while execution of the lower priority process, in preemptive execution, the lower priority process which is executing in the CPU currently will be placed on the ready queue or waiting queue, and the process which arrived with the higher priority will be allocated for the execution. This is preemptive. In non-preemptive, it's vice versa. The thing is that even though a higher priority process has arrived and currently lower priority process is executing in the CPU, after completion of the lower priority process, the next higher priority process will be allocated. This is non-preemptive. Okay, in this, let's see the example elaborately.